Well, hello everyone. I have been asked to do a geometric series problem. So the problem that I have chosen is the sum k equals 3 to infinity of 3/5 to the k plus 3. And the big thing is trying to adjust these exponents so that, this exponent and this counter variable so that it matches up with the form that we need it to be in, where it's k equals 1 and then we have k minus 1, or n equals 1 and then we have n minus 1, so that we can apply the series sum component. Now, we need to figure out what the a is, and what we do, and I've been trying to figure out a quick way to do this, and we've had some discussions about sort of a fast way to be able to come up with the a and come up with the format without having to think too much about how these work out. And so what I came up with is the following. Forgive me. So let's write out the terms. So we're going to start with 3, plug 3 in, so we're going to have a 6 there. And then we're going to add on, when this is 4, we're going to have a 7 there. When this is 5, we're going to have an 8 there because it's k plus 3. Now, each one of these terms has a 3 over 5 to the 6th power. So it's factorable. So we're going to pull out that 3 over 5 to the 6th. This is what the a is going to end up being in that formula where we have, now forgive me, so you're going to have that a over 1 minus r. Now, I write it differently. I write it as a times 1 over 1 minus r, and you may see why in a second. So here sits the 3 over 5 to the 6th, the piece that's factorable. And then I'm going to write the remaining series out. So I'm going to have the 1, because this is pulled out, and I am reversing my factoring when I think about it as, oh, I've got to get back to here. So 3 over 5 to the 6 times 1 is there. 3 over 5 to the 6 times 3 over 5, well, we add our exponents, we're there, and so forth. So the way this looks is we have 3 over 5 to the 6th, and then I have my k equals 1 and my k minus 1 with my 3 over 5. And if you write this part out, well, when k is 1, 1 minus 1 is 0. 3/5 to the 0 power is 1. And then when k is 2, 2 minus 1 is 1. 3 over 5 to the first power is there, and so forth. So what happens is this piece becomes 1 over 1 minus 3/5. And this piece is our a. So now we're down manipulating this factor of these two. So I'm going to have 3 over 5 to the 6th times 1 over 1 minus 3/5. Well, get a common denominator. We end up with 2/5. We divide by a fraction, so we flip the fraction and convert it to multiply. And I'm just going to put dot, 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 because you can figure the rest of that out. We also have an issue in one of the problems. I think it was e to the negative 2k, or it might have been e to the k. I don't remember, or e to the negative k. I don't remember which. And so just as sort of a highlight, when you see that negative on that, you can think about it as 1 over e. And because 1 to the kth power is the same thing as just 1, we can rewrite this as 1 over e to the k. Well, e is about 2.718-ish, so this is a ratio smaller than 1, and so this will converge. And we just repeat the process that we did up here. Write out the first couple of terms, figure out what's factorable, and then this component in here fits our model, and then we have the 1 over e as the a. I hope that helps.